Morning, everyone. We're just waiting for everyone to kind of get into the room, and we'll get started here in just a few minutes.
Let's wait just one more minute and then we'll start.
Excellent.
Okay, guys, let's start. So thank you very much for being here with us. My name is Vera, and I work in the marketing department of Control Station, and I will be hosting this webinar with Zaire and Bob. So our webinar is Unlock Plant-Wide Optimization with the Power of KPI Explorer. And before we start, I want just to let you know that here in the control panel of the GoToWebinar, we have a section named Questions. And anytime you want, you can just write your questions. And in the end of the webinar, Zaire and Bob are going to answer those questions, okay? So our presenters are Bob Rice and Zaire De Leon. Bob has over 20 years of engineering and product management experience in the process industries. As a recognized thought leader, Bob oversees development of Control Station's award-winning suite of process diagnostic and optimizations technology, including Plant ESP control loop performance monitoring solutions. And Zaire is a field application engineer at Control Station, responsible for deployment, use, and support of Control Station's award-winning solutions. He previously worked in operations in Connecticut tobacco industry and has his BS in mechanical engineering from the University of Hartford. For those who are new to Control Station, we have been an active innovator since the 80s. Today, we are proud to support an increasingly global clientele, and our customers include leading manufacturers from across the process industries.
Excellent, thank you, Vera. So today we're just looking to have a conversation around PID control, monitoring, and what you can do to make your facility just a bit more efficient. Right? We're all familiar with the PID controller. It is the fundamental building block of most industrial manufacturing facilities today and has been in use for over 100 years, so it is not going anywhere. The importance of ensuring that your control loops are running smoothly at all times, frankly, cannot be understated, right? You wouldn't build your house's foundation with cheap wood and shoddy concrete, so you wouldn't accept anything less than near perfection from the control loops that serve as the foundation for your production environment. We're also going to take some time to talk about control loop performance monitoring, right? A means of getting more eyes onto the numerous automated processes you may have within your plant and gaining a deeper understanding of its typical operating levels and the relationships it may have with other control loops. Right, the automation world is a very different place than it was a decade or two ago. And with the sheer amount of information that every plant now has at their disposal, it has become, frankly, impossible for any one individual to consume it all in a reasonable amount of time. So, what do we do? What do we do about that?
Yeah, and so when I think about control loop performance monitoring, we think about kind of the advancement of the tools. What are the changes and new features, and how do these tools grow with us as a society, right, or as a group of engineers, right? You don't want to be using the same process from 20 years ago because your plants have changed, the access to data has changed, and so one of the things we try to do at Control Station is to rethink through the problem, right, to try to understand what are the challenges that engineers have to go and identify issues and identify problems. And the answer is it's got to be quicker, it's got to be simpler. You really got to minimize the amount of clicks, and you'll hear me kind of talk about that throughout today's presentation. Is you don't want to spend a half a day finding the problem, right? You want to be able to get there very, very quickly, find the issue, and get to an actionable correction very, very quickly, right? And that's really where a lot of today's discussion around application advancement will kind of focus around is what can we do to make it quicker and easier? How can CLPM software make this faster for you to do? We'll also talk a little about some of the other innovations around the product suites here at Control Station relating to configuration, operation, and into the cybersecurity realm, right? Let's go ahead and go to the next slide. So we're going to start a bit with a survey. So, one of the biggest questions I always have is, how do you identify poorly performing loops today, right? I ask this of all of my colleagues and our customers and so forth is, how do you do it today, right? And the answer is a lot of it is I just wait for somebody to tell me something's wrong, right? Squeaky wheel gets the grease and you're going to go and fix that. A lot of times you may be in the control rooms. You actually have to be in the control room and you're working with the operators, you're looking at the panels and you're looking at the displays to identify problems and so forth. You may have tools in your office, right? So are there tools that you're using in your office, desktop trending applications to be able to identify issues? Or do you utilize a CLPM style tool to do the work for you? Or the bottom, which is I'm not involved at all, which is kind of strange that you'd be sitting on a controller performance monitoring talk if you're not part of that job, but hey, sometimes you just like to listen to webinars, right? So the idea here is, are you reactive? Are you in the control room? Are you in your desktop, or have you built or use CLPM software to do that kind of heavy lifting and so forth for you, right? And it just helps us kind of understand and gear this talk to help us, make sure that we hit the high points for what people are after here.
We have the answers here. I will just close and share the results. Just give me one second.
Brilliant. Right, and yeah, this is typical. You wait for others to notify you of the issue, right? I mean, that is the process, right? You wait. The operators call and say, hey, there's an issue with this steam loop. There's an issue with this process. There's an issue over here. Go fix it, right? I see the two other ones near the bottom are desktop trending tools and CLPM, right? That's kind of that's excellent, right? That means that you now have access to all of that wealth of data that's available out there now, right? Using the trending tools and the CLPM tools and so forth. Zaire, does that kind of match up with the conversations you've been having with customers?
Yeah, I would say that's pretty accurate, right? Most people, as you've already mentioned, they're just waiting for something to happen, some kind of adverse event to hit the facility, and then that's when they actually go and address the poorly performing loops, right? A lot of people aren't analyzing the loops and finding the issues before they actually start causing some significant problems. And so let's, if you want to go to the next slide, I want to talk a little bit about our PID blocks, right? So the past century or so has kind of proven the prevalence of the PID controller, right? They're not going anywhere. And as we know, a PID block can react to changes in a process behavior and bring things back under control just significantly faster than a human operator ever could. They use less input material, they show less error, and they can ensure the safety of our operators and engineers when unforeseen situations arise. The problem comes with ensuring that all of these control loops are functioning as they are meant to be, right? In a small aggregate facility where you're making maybe one or two types of concrete, you could have a couple dozen PID loops that can be easily understood and monitored by control room personnel, right? They have a deep, intimate understanding of that small process. But the same cannot be said for, let's say, downstream operations in the oil and gas industry, right? These refineries have thousands upon thousands of PID control loops, all interacting with one another and responding in such a way that, frankly, it would take decades for a single person to understand every single interaction and every single quirk within that system. And that's assuming nothing has changed, no equipments get upgraded, no process modifications. So it's a completely impossible task. And so for a lot of manufacturing facilities, PID controllers tend to exist in this gray box that doesn't get any attention until things start to go awry, right? We know that ensuring our automatic processes are running efficiently is important, but how much does it actually affect what we're doing if our PID controls are not running efficiently, Bob? What would you say?
Yeah, and with all of these loops at all of our sites, right? Even if it's 30 or 40 of them, trying to maintain all of those can be a full-time job. And let's face it, there's not anybody who has a site that's got 50 or even 1,000 loops whose full-time job is to just constantly look at the PID controllers. You're reactive, right? You're waiting for these problems to occur. And when a problem occurs, that means stable operation has been impacted, and now you're constantly in this kind of reactive state. So what are some of the benefits that you can get out of it, right? This is all well and good. Everyone knows you've got a lot of work and a lot of PID controllers to analyze. So next slide, Vera. So, there's been a number of studies over the years about trying to quantify the economic impact on everything, right? And determining ROI and return on improving controller performance, it's been well documented time and time again, right? There are so many opportunities, and the cost of poor control is significant, right? Poor control can be attributed to a 5 to 15% increase in energy consumption, right? Increase in product defects, decreasing product yield, decreasing production throughput, just by not having your control loops optimized, right? One of the easiest ways to kind of document return and show the value of controller performance is to go after energy loops, right? Those are some of the easiest ones because everyone's got their eye on the energy costs, right? You start looking at steam, you start looking at your cooling and utility systems. You identify all the temperature controllers, right, that are using, steam, for instance. You go and you tune those loops, remove the variability, move the set point up or down by that variability that you've removed, and you can very easily recover 2 to 3% energy costs just by doing that very simple exercise, right? And that can be a very large number depending on the complexity and size of your plant. The ROI is there. It's been documented time and time again, right? If you need help trying to document some of the ROI or work on projects, let us know. We've done quite a bit of work in that area. We've got a number of case studies out there that have been published, right? The value is there, right? And this is really important now because we've got a lot of data. We're starting to track a lot of this stuff, and that improvement to data access, the amount of data that we're actually archiving, whether it's production, process control data, whatever it is really starting to kind of drive that kind of, and I hate buzzwords and stuff like that, but that kind of, IoT type of industrialization. So, Zaire, what are some of the changes to kind of the data prevalence that has been out there over time?
Well, the amount of data that we have just in the world in general has changed drastically over the past few decades, right? With the advent of Industry 4.0 and the, as you said, the industry Internet of Things, right? On the commercial side, of course, the Internet of Things, personally, I'm not a fan of having toasters with Wi-Fi connections, but on the industrial side, it has provided us with a significant amount of benefits, right? We now have access to just an absurd amount of data. Vera, if you want to get to the next slide for me. And that's only really possible due to the decreasing cost of sensors, right? A decade or two ago, a handful of extremely powerful and precise sensors may have been like a strain on a facility's operating budget. But nowadays you can buy, 200 extremely precise down to maybe 0.001 precision sensors for, maybe $100 online, right? Things have changed drastically. And so now just the sheer amount of information that we can gather on our processes, from our temperatures, our flows, our vibrations, every single aspect is now being recorded and being stored somewhere for us to analyze. Now, all of that data doesn't really do us any benefit if we can't process it, right? And so with our addition of new powerful processors, right, multi CPU and GPU units, we can actually do something with this prevalence of data.
Mhm.
Of course, with all that data, right, we want to know, or it doesn't do us any good if we're not doing anything with it, right? We want to take that information and gain some insights into our processes, right, through data analytics. When an adverse event happens that impacts production, we can do more than just fix it and get back to normal. We can actually figure out what the cause of that failure was, why this event even happened in the first place, and maybe identify some potential warning signs and indicators that can alert us when such an event may happen again, all without having to leave our desks. We know how important this data that we are capturing is, Bob, but what are some of the ways that we can actually start by processing and analyzing it?
And it's kind of interesting is there are a ton of analytics, and the analytics aren't necessarily new in discovery. They're only new because we now have the capacity to be able to run them on thousands of data channels and so forth. And I look at younger engineers like Zaire who didn't have 20 years ago you couldn't get data, right? The data just didn't exist, and if you tried to grab 50,000 tags out of a DCS, you could crash the DCS, right? Now you can pull that stuff out. You've got the processors, you've got PLCs and DCS processors that are as powerful as crazy things now. It's insane. And so the data analytics that we can pull out of it, we can start running analysis on thousands of control loops simultaneously. We can start being able to pull that data out, understand the interconnectivity of our process variables, of our controller outputs. That capability is there. We're in this age of abundance of data and the ability to do analytics, right? And so it's really key is that we got to focus on these analytics to determine what is the value we can get out of it, right? Data for the sake of data is a waste of hard drive space, but data for the sake of actually generating valuable information, that's where the power is. And Vera, if you can go ahead and flip to the next slide. So if you think about controller performance, which is really what this talk is about, we're trying to focus on analytics that are really designed to help us determine, are there tuning issues? Are there mechanical issues? Are there, process related issues? Trying to look at things like variability associated with controllers. Looking at, is there saturation detection, saturation on the valves? Is there stiction on the valves? Is there cycling in the valves? Is there oscillations? And how much of the signal variability is due to one oscillation? There's a ton of analytics that can be performed that are very, very valuable. And you can start to roll this information up to be able to help you really identify and prioritize your issues. And this can be done on thousands and thousands of controllers simultaneously to be able to help you to do your job on a day-to-day, identify the 10 worst loops or the 5 worst loops, right? And the idea is that you've got a number of different analytics that can help prioritize your issues, but you also need some tools to be able to help identify root cause, because sometimes the squeaky wheel that you keep going to isn't actually the origination, right? It's it's something else associated with the chair. And I'm sorry, I'm not a chair engineer, so I don't know what else could cause a squeaky wheel, right? But the idea is that there are other loops that could actually be driving the variability. And so Zaire, what are some of the kind of forensic tools and so forth that you've used, and some examples that you've used out in the field to maybe say, hey, there's a loop here, but there's something else that's actually driving the variability?
Yeah, so I actually had the chance to use some forensic tools pretty extensively last year with a customer of ours. They were experiencing a pretty significant oscillation in their steam header pressure, right? And this is a pressure that supplies the vast majority of their processes. So every single control loop was showing some degree of oscillation, and that was impacting the quality of the product that they were putting out. Now, traditionally, right, just trying to figure out where the heck is this oscillation coming from can take days, weeks, months. If you have lots of PID loops, you got to go through every controller, every valve, every sensor just to try and see what is wrong. But with the forensic analysis tools, we can very quickly see, okay, what are all of the control loops I have that share a single oscillation, and which one of those is actually the origin point, which one is seeing it before all of the others. And so using these forensic tools, we're actually able to identify a single valve that was set up incorrectly. It was supposed to be a continuous control valve, but it was actually set to on-off mode. And so, right, if you're constantly flipping your steam from no steam to full steam to no steam to full steam, that's going to lead to a bad time. And so CLPM provides us with a significant amount of benefits. And we have another survey here for you guys. This one, on which best describes your functional responsibility, right? Now, it is 2025, right? And we tend to wear many, many hats in our jobs. We are engineers in IT and OT and all things in between. But which of these kind of best describes your role right now, right? Now, naturally, maintaining safe operation across the production environment, that is something that is everybody's responsibility, right? And it's really our number one priority, ensuring that all of our engineers, our operators, our maintenance staff, everybody's able to go home safely to their families. But these others, right, maintaining asset reliability and eliminating downtime, right, that is incredibly important. The longer you're down, the more money you're wasting, and typically our bosses do not like it when we are down for unnecessary periods of time. Or are you more focused on ensuring that that final product is actually coming out and ensuring that the limited process variability is not significantly impacting that variability? Or even are you supervising all of these various teams? Are you looking to get a better overview of how your various teams are functioning and how they are performing their duties, right?
Okay, I'm going to close the poll now and share the results.
Keeping production quality and limiting process variables seems to be the vast majority. Okay, yeah, that makes sense, right? Why individuals who are focused on ensuring that this product goes out and stays within our thresholds would benefit a lot from controller performance monitoring, right? The ability to know exactly when a process is starting to show signs of poor performance before it actually impacts the process can save significant amounts of time and money. But CLPM does absolutely have a wide variety of applications to not just ensuring process variability, but right, ensuring you're safe, that your loops are operating within safe constraints, that things, that your valves are operating as they should be, and that you are not missing out on any potential throughput.
Excellent, excellent. That was really good, and I love seeing that a ton of people focused on process improvements and decreasing process variability. And what's kind of interesting is there were no managers on there, which means that everybody on this call is people who's doing stuff, right? Love it. All right, so let's think about traditional CLPM controller performance tools, right? You think about what they're doing is relatively well known, right? You're going out, you're pulling in data from your system, and you're trying to find opportunities. But how do you interact with these tools? A lot of tools are designed to give you a lot of functionality. You got tools, you can click around, you can find heat maps, you can explore the loops and the behavior, you can go dive into that particular loop, you can go find the problems, right? And there are reports and stuff like that, but that workflow, it's a lot of clicks, right? It's a lot of process to get from A to B. It's a lot of information. You can do a lot of exploring, right? And you can do a lot of exploration of the controller performance, trying to identify where your problems are. It gives you a lot of capabilities, right? It does lower that cost of curiosity to be able to go and do the investigation, but it takes a lot of clicks to get there. And the challenge that we've always run into is people want a very, very simple way. What am I going to do, right? What is my goal for today? What is the main point of interest that I'm after? And so traditional tools go out, they identify opportunities, they create databases of results, they create reports, they create another essentially silo of information that you have to interact with some way. And that can actually cause some challenges in how to actually use this tool. Zaire, what are some of the challenges and so forth that you've seen as essentially an end user of this tool for Control Station? What are some of the challenges that you've experienced, using CLPM and what you've heard from customers?
Yeah, I'm really glad you asked that, because CLPM is fantastic, right? As a naturally curious engineer, it has been an amazing tool in order to get to the root cause of issues and learn more about my processes. But there are some limitations with it. And I would say possibly the biggest limitation is the requirement of significant process knowledge, right? CLPM is able to take all of the data that your process is spitting out and provide you with a ridiculous number of metrics that will inform you how it's performing, how it interacts with other control loops, but it can't tell you whether those metrics it's calculating are good or not, right? It can't tell you whether the excessive movement you're seeing in a final control element is par for the course in anticipated behavior, or whether it's something that needs to be addressed by you. Nor can it tell you whether a valve that's been saturated at 100% output for a few hours or a few days is actually totally fine, because it only triggers when the process gets above a certain threshold, right? Understanding the relationship between the metrics can be tricky as well, right? The metrics are just like your control loops. They don't exist on an island. They interact upon other loops and metrics, and they're interacted upon by other loops in metrics. So how do you know when a particular metric that's showing in the red is actually, is it because the process itself is doing poorly, or is it the result of 5 different steps of metrics showing, okay, my oscillation is bad, so that means maybe my AAE will be bad. How do I manage all of these this information and make sense of it to get actionable items, right? Something that I can actually take and bring out to the field and give to my maintenance staff, my operators, to make changes to the process, change out a valve, maybe even do new tuning, right? It can be quite difficult to get that information. What about you? Have you found any challenges in using this tool?
What's interesting to me is it's always about trying to get to the actionable piece of information as quickly as possible, right? For me, whenever I want to use a tool, I want to get to the answer immediately. I'm an engineer. I love poking around and finding things and doing that kind of exploration. But the truth is, we are all incredibly busy, right? And so we need to get to the actionable information as quickly as possible. And so when we were thinking about making improvements and changes to Plain ESP, we went out, we reached out to customers, we talked with our user group to try to determine, what are the issues that you're seeing, how can we do it? And the number one response is, I want to get to the answer more quickly, right? I want to get to the answer more quickly. I want to interact with your data more easily. And so that's kind of where the KPI Explorer and the idea behind that kind of came out of. And so go ahead and next slide, Barrett. And so we kind of start at the same page as we did before, but the idea is to be able to very quickly understand the challenges, right? And so now, whenever you click within the pages for the summary details and so forth, if you click on the red area, percent time and normal, it instantly just says, here's the loops that are in the wrong mode, right? And then you can do your diving and your analysis much more quickly. You don't have to go and say, okay, well, yeah, I've got 8 loops that are in manual. What 8 loops are those? Well, I could go to a report. I can go to the heat map, I can go to the table, I can sort, but now it's designed to be very, very quickly. And this type of change really just facilitates you exploring more data opportunities. And in a moment here, Zaire is actually going to show you a little bit more of the filtering and the capabilities. But the idea here is minimizing the clicks, right? The home page should show you where the problems are in red, green, and yellow for all the different KPIs and metrics, and very quickly get to what are those metrics, right? And what are those loops? And what are the explorations that you can do? What are the loops that are oscillating, the loops that are in the wrong mode? Get to that answer very, very quickly without actually searching around. And then even on top of that, be able to manipulate and explore the data in other ways as well to be able to get to that list of answers in as little clicks as possible. Zaire, what has that kind of done and changed your workflow? How has that changed your workflow with the tool?
Oh, I'm a very, very big fan of the KPI Explorer. It's probably one of my most favorite features as it's been released in the past few years. It has significantly reduced the amount of time I need to take in order to find some seriously useful, actionable items. And verify, am I going to the next slide for me? So the KPI Explorer is incredibly powerful, but also incredibly simple to use, right? So when you're accessing the KPI Explorer, you have the ability to filter by whatever processing area you want, right? Whatever units you have already set up. And that's pretty typical. That's par for the course. You can do that. You can already do that in our tool. Where the power really comes from is the ability to then take data from those particular areas and filter it however you would like. And so in the little GIF here that's showing, we see that, right, we can decide what type of control loop do we wish to analyze. Okay, we want to look at a flow loop, so we're only going to grab data for our flow controllers. And then say we also want to know which of these flow controllers are actually in the appropriate operating mode, right? Which ones are running in automatic or cascade, and which ones have been stuck in manual or error for who knows how long. And from there, all we do is we select, right? We want to know the percent time in normal, we want to know the type, and we will get our results. And if we want to add even more filtering to said KPI Explorer, it is as simple as, well, clicking on the filtering and adding a new result, right? So the benefit to this is that the data is now extremely dynamic, right? You're not limited to just a single report of loops that have poor percent time in normal or loops that have poor saturation, right? You can very quickly change what your filtering criteria is without having to even change pages. So if I decide, okay, maybe I also want to add an overall health threshold to this, or an deviation from set point threshold to this, I can add those as filters, and now my data will say only loops that are in the correct mode with outside of this deviation range and have this much movement are going to show up on this result. So once you know exactly what it is you're looking for, at least have a good idea of what kind of data you want to look for, this allows you to very, very quickly get to that information. And you can very easily export those results to then go on and do some more advanced investigation. So this tool has been changing in my workflows, absolutely. Outside of this KPI Explorer, though, what are some of the other new features that we've been looking to add, or how has the KPI Explorer helped you out as well?
Yeah, what's interesting is that KPI Explorer, and I use this phrase a lot, it lowers that cost of curiosity. You want to be able to find opportunities and action items a lot quicker. And as Zaire had mentioned, you can use this and do your exploration and create your own filters. But we've also created these kind of predefined searches. And so when you click from the home page on the PTIN, it automatically sets up the filter to say, oh, you're interested in the loops with in the wrong mode, or loops that are oscillating, and loops that have high AAE. You can very quickly get there, and it kind of pre-builds that query. The idea here is it just allows you to interact with the data in a lot simpler, quick fashion, right? Lower the number of clicks, right? And the idea is we want you in and out of plain ESP as quickly as possible so you can start solving the problems, right? If you're spending 3 hours clicking around a tool to try to find the opportunity, that's not what we want, right? We want to be able to get in and out as quickly as possible. And so if we think about some of the kind of enhancements and the changes that we've made to the software this last release, the KPI Explorer was the major release, right? That actually added a lot of functionality and a lot of capability within the tool, but that wasn't all that we've done. I'm actually going to start on the right because the security thing is probably the most important in today's environment, right? We want to make sure that the software follows best practices for software development lifecycle. And so in this latest release, and what we've been doing for a little while, is pen testing. So we've got, if you're a current customer and your IT group says, hey, look, we've got this ESP software, what's its security protocols and standpoint, and are they doing anything, right? All of our software is continuously penetration tested, right? To make sure that there are no vulnerabilities attached to it. We have a full report that shows all compliance. We also do nightly vulnerability analysis on all third-party DLLs and files and so forth. If you're following IT, there's always vulnerabilities that crop up on you know, the log4net stuff and Java stuff, and you know, the white hat hackers that are out there and identifying these vulnerabilities and publishing them, right? All of this stuff is analyzed every single night, and every release that we've had of Plain ESP goes through all of this vulnerability and threat assessment every night. And if there's a previous version of ESP, we can actually track down which version it is. We make sure that the current version follows all best practices, and we've got documentation to back up that all of our stuff is continuously analyzed and that it passes all threat assessments and vulnerability analysis, which means that we are constantly improving the back end and the framework of which Plain ESP is built. And this is no small matter, right? Making sure that the software is always up to date, always following best security practices and so forth is always a heavy lift, right? But that's something that is very important to us at Control Station to make sure everything is there. We've also worked heavily on database optimization, minimizing the footprint, right? What can we do to make ESP faster, take up less data space, to be able to provide more capabilities to interact with third-party tools, so things like REST APIs, to ensure that all of our data can be accessible outside of our tool as well as internally, right? And a lot of configuration, right? Maintaining these tools is always a challenge. So we're always trying to improve the administrator portal, the importing, the configuration of loops, the AF integration with the Aviva system has been improved even more. Being able to scan and sync with asset framework models to be able to make sure the system stays configured appropriately, amongst a lot of other operational changes, right? If you're a current version, a holder of Plain ESP, those are always opportunities for us to reach out. We can share release notes, we can get you up to date, right, to make sure that you've got the most modern, solid version of Plain ESP that's out there, and we are always doing new improvements. And so if there's any questions, anybody on the call, you know, please let us know. With this last release, Zaire, what are some of the things that you noticed for your deployments and so forth?
Yeah, so things have changed a lot, right? It's been a lot more streamlined, right? A lot of it is just quality of life improvements, right? Ensuring that when we're using the tool, things operate the way they should, and they're easy to use, they're understandable, right? The accessibility is there. Yeah, the speed of the software has been improved significantly. Overall, right? There have been significant changes that I'm just been a big fan of.
Mm-hmm. Excellent.
Great.
I think we're right at the end here, Vera. Mm-hmm.
Yeah, I have a final survey that I'm going to launch now.
Mm-hmm. This is great. So this is where you get to ask us if you need any help. If you need help with understanding the benefits of CLPM, you know we're happy to help with that. Me and Zaire especially, if you have an existing Plain ESP deployment and you need to get updated to the latest version, please let us know, right? We're in the process of reaching out to current customers to get them updated. There are a number of new features and enhancements that have come out. We're more than happy to have a one-on-one call and show you all that's changed from your version to the current version, all of our release notes, and we can get you updated, right? If you're under maintenance, that's something we can help you with, and that's not an issue, all right? Services to help improve your plan's productivity. If you need any help doing audits or helps even using Plain ESP to show value, those are things that we can definitely help you with. And any training classes and webinars that we're holding, you know, more than happy, you know, you should check all of them, right? Get all the information, right? But if you got a current ESP system and you need help updating and deploying, that is definitely something that we wanna help with, and we're there for you.
Thank you, Bob. So let me just close the poll, and I think we can go to our questions.
Mm-hmm.
So we have 3 here. What KPIs are the most important when getting started with a loop monitoring solution?
Yes, that is a question I think me and Zaire have gotten almost every single conversation with an ESP deployment. And my answer is always try to start simple, right? And start with ensuring all your controllers are in the correct mode, right? That is That is step one. If things aren't running in automatic, there's no sense looking anywhere else. You got to get things running in automatic. Once things are in automatic, then you start having to look at the performance related to them. Then you're going to start looking at things like oscillation or AAE and output travel. Those are kind of my three big metrics that I tend to use. Zaire, what is your approach?
Yeah, so I agree. The absolute worst thing you could do is just start right off the bat with all the metrics going and trying to figure out ACE and oscillation and output travel and all these different metrics at the same time, right? It's a fire hose of data, and it's going to frankly overwhelm you. It overwhelmed me when I first started doing this because CLPM does produce a lot of data. I'm inclined to agree that operating mode is probably one of the most important things, right? If your PID block isn't running, well, then nothing else is going to frankly matter. Depending on what it is you're looking at, right? Oscillation is a very important run, right? Oscillations tend to propagate throughout production facilities. And if you have a particularly bad one at the very start of your process, well, that's just going to completely screw everything that comes after it. So oscillation is another one that I like to really hone in and focus on to make sure it's not causing too many issues.
Excellent. Excellent.
Excellent, thank you. The other is we recently licensed Plant ESP at our facility. How hard is it to upgrade to the newer version?
The update is actually very painless. If you're running, a plain ESP version from the last few years, one of our engineers can get on a call with you, walk you through the process in probably 30 minutes, get you updated and moving on. So it's a very painless process. The team is very proficient at getting you updated. And so if there are systems out there and you need some help, let us know. They can hop on a call and get you going.
Yeah, we've got this down to a science at this point, so our upgrades are pretty efficient when it comes to that.
That's great to know, thank you. And the last one is, how do I know if my plant is performing well? How does the CLPM software knows that?
Yeah, and a lot of that is about baselining, right? What is good, right? What is good control? Where does that actually lie? And there's been numbers published over time. If you think about percentage of controllers in automatic versus manual or normal mode, like the average that we see out there, and this is still to this day, is around 70 to 75% of controllers are in the wrong mode, right? Which is astounding to be where we're at. Best in class is sitting around 90% or above, right? And so you've got a lot of capabilities within CLPM or plain ESP to be able to track your performance. We've also got a fleet of deployments out there, and we've got information that allows us to say, okay, look, across all of our fleet, the average is here. Where do you sit to be able to understand where you rank within quartiles of what typical performance is? And so we use a method of analysis called OCE, which stands for Overall Controller Effectiveness. We've done some webinars on the past. We've got some white papers on that. That is a normalized metric that's used to track plant-to-plant performance, identify low-hanging fruit, and it's essentially the product of the percentage of time in normal, time not saturated in AAE. We've got a number of webinars coming up this webinar season on that topic, but that is a really good way to help you understand. But again, that percent time in normal is an excellent plant-to-plant type of analysis. Where do you stand, right? Again, our out of our fleet of customers, our top tiers are sitting above 90%, right? And so if you want to target above 90% is good control. If you're above 90%, you're doing pretty good. There's still opportunity, right? But that's kind of one way you can do plant-to-plant. Zaire, is there any other recommendations you have or thoughts around that?
No, I actually think you covered my thoughts pretty well. Yeah, nothing to add there.
Excellent.
We have one more, Bob and Zaire. So can the control loop performance monitoring differentiate between the ideal PID equation and the interactive PID equation?
Yes, one of the configuration parameters when you're setting up CLPM software or plain ESP is to actually specify the type of PID block that you're operating. whether it's a Honeywell equation B series or Delta V standard or whatever the different forms is, that's actually a configuration requirement, is for ESP to know the difference of the different PID blocks, because one of the calculations it does is a tuning deviation and a tuning suggestions module. And so to be able to calculate the tunings and understand the behavior of the process, we need to know what type of controller it is. And so yes, it can differentiate, and there's a library of all the modern controllers. So you don't even technically have to know if it's independent or dependent. You just have to know, oh, I'm using Honeywell equation B, right? And it will do all the underlying conversions and math for you.
That's great, thank you.
Mm-hmm.
So thank you very much for all being here. Here's the contact of our specialist. We have different people for different place in the US. We have Middle East, Africa, Europe. So you can just scan the QR code here that goes directly to our website, and you can send your questions, send us some contact information for us to call you. And for the last, but it's our next webinar that's happening on March 25 with the title of Mastering PID Control, the Art and Science of Tuning Cascade Controls. So with the QR code here, you go to the page that you can register for this webinar. And every month we are having a different webinar that covers PID related subjects. Thank you very much, and I hope you had enjoyed and have a great week.
Absolutely. Thanks, Vera. Thanks, everyone.
Thanks for attending, people. Appreciate it.